So the first question on the document posted for today's class, we have a 5-card hand. That is, we're going to deal 5 cards without replacement. We're going to take 5 cards off of the deck. And how many ways can that 5-card hand contain exactly 2 of the 5s? So we have 52 cards here, 52 possible cards, and how many ways can we get exactly 2 of these? Well, as we see, there are 4 5s in the deck, and the order in which we get our 2 5s makes no difference. The hand is going to be the same. If we have a 5 of hearts and a 5 of spades, let's say, it doesn't matter which one we got first. We have the 2 cards. So getting a 5 of spades, then a 5 of hearts has no different, well, if we get a 5 of spades, then a 5 of hearts, or if we get the 5 of hearts, then the 5 of spades, we have those 2 cards, and that's all that really matters. Okay, so the order of the 2 5s doesn't matter. There are 4 5s in the deck, so there are C of 4 2 ways to get the 2 5s. Now, and that, of course, that multiplies out to 6. We apply the definition, and I'm assuming that everybody knows how to calculate C of 4 2. Now, we found out in class that even after the test on the counting chapter, not everybody knew how to do that. So we're going to talk about that in a minute. We're going to digress in a minute and talk about how to evaluate that. But in doing these problems, once I get it down to a C of 4 2 or as a C of 48 3, I simply assume that everybody can do that calculation and work that out. So in doing these problems, I won't always write down what that equals. Okay. Once we've got C of 4 2 or C of 48 3, that's could be as far as I'm going to go, because the rest of it is just the mechanics of evaluating the combination. Okay, so well, in any case, we see that there are C of 4 2 ways to get 2 of these cards, and I could list them. We could get these 2, or 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 these 2. That's it. That's the only possibilities. And there are 4 ways to choose the first card, 3 ways to choose the second, but it doesn't matter in which order we do that, so we divide by the 2 possible orders in which 2 given cards could appear. Okay, having chosen 2 out of the 4 5s, we now need 3 cards that are not 5s. Okay, now we've chosen 2 cards. There's still 50 cards left in the deck, but we can't, in order to get exactly 2 5s, we can't choose one of the 2 5s that remain. So again, having chosen 2 of the 5s, there are still 50 cards left, but 2 of those 50 cards are still also 5s, and we can't choose them. There are only 48 cards that aren't 5s that are left in the deck. In terms of the picture, we've chosen 2 of these. Now we don't choose any more, so we have these or these from which to choose the remaining cards, and there are 48 of those because there were 52. 4 times 13 is 52, and now there are only 48 cards from which we can choose the 3 to fulfill the condition being that we get exactly 2 5s. So there's C of 48 3 ways to make those choices. So we make the choice of 2 of the 4 possible 5s, then we make the choice of 3 of the remaining 48 cards, and that gives us our 2 5s, and the number of ways of doing that is the product by the fundamental counting principle. We do this and we do this. So we multiply this number of ways of doing this by the number of ways of doing this. We don't worry about what that number is, although you would want to work it out. We're not going to worry about that right now. Simply worrying about the fact that we're choosing these cards and the order doesn't matter, so we have combinations.